Well, hello guys and welcome back to Mr. G Physics. Here's Mr. G, and this time we're going to be finishing the control question done in the Northern Cape in 2024. This one is question 7 and is the most problematic question in this specific phase control test. It's about organic reaction. So let's see how we approach this question. But before, don't forget to subscribe to the channel so you can get all the notifications and videos I post on regular basis. Now, this question say in the flow diagram below, 1, 2, 3, 4, and 5 represent organic reactions. And then before we move on, let's have a quick starting and understanding here. Reaction 1 is going from an alkene to an alkane. And guys, I'm going to tell you this one. Since the moment you start with an alkene, it means the reaction is going to be addition. So reaction 1 is addition. For sure is going to be addition because you're starting with an alkene. Nothing to say about that. Question 2, you also start with an alkene, therefore is addition once more. Right? And the opposite is elimination. From 2-bromopropane to an alkene, you starting with a saturated compound, you finish with an unsaturated, therefore this one is elimination. Since the moment you finish in an alkene, that is going to be elimination, therefore 5 is also elimination. It's simple. If the product is going to be an alkene, it's elimination. If the reactant is an alkene, that is an addition. And then the 4, you starting with a haloalkane, you finish with alcohol, this one is substitution. And now we have the main type of reaction in each case. We can go in detail, but let's leave this one for later, for another time. Question 7.1, name the type of reaction represented by 1. We already say is addition. Now, to be more specific, in this case, you can, but I recommend to write addition rather. We go for alkene to alkane, therefore they add hydrogen. This one is hydrogenation. This is hydrogenation. Why hydrogenation? Remember, they add hydrogen. Okay? Question, the second one is reaction 2 is also addition. So reaction 2 is also addition. It's also addition. In this case, you add hydrohalogen. So this one is hydrohalogenation. I have videos for each type of reaction. I will leave the link down below here so you can get this one clarity if you still don't get it right. And reaction 5, we end up in an alkene, we say is elimination. Is elimination, and you can see that you're starting with an alcohol, you end with an alkene, so it's quite simple. This one is dehydration. You're removing water there. So this one is the first part. It's quite simple, guys. It's really simple. Question 7.2, write down the reaction in which platinum is used as a catalyst. And guys, let me tell you something. Platinum is used as a catalyst in only one reaction, so you have to memorize that one, and that reaction will be hydrogenation. It's the only reaction in which platinum is used as a catalyst, okay? That is hydrogenation. And therefore, if we go back here, that will be reaction 1. So it is reaction 1. That is the answer for this question. It's not that bad, but you have to memorize. Okay? Now, choose from 1, 2, 3, 4, and 5. We already say is reaction 1. For reaction 3 and 4, a base is required for the reaction to take place. Now, let's say something here. Which bases are we going to use? We always use strong bases. And that is the next part of the question. Write down one similar property of the base required in both reactions. Guys, those must be strong bases. There is a difference between strong and concentrated. Don't get confused. Don't get confused. It's quite simple. You will eventually learn about that in grade 12. Strong bases. But in grade 11, you already mentioned that on strong bases, for example, is NaOH. This is one example. Or LiOH. Or KOH. Those are examples of strong bases. It is, in other words, any group 1 element hydroxide will give you a strong base. Now, which is the difference between the bases we use here in reactions 3 and 4? I don't even have to go and see the reaction. I know they're speaking about two reactions. One is elimination and the other one is substitution. During elimination, because you're eliminating, you need concentrated. But during substitution, you need dilute. All right? So all we have to say is to come back here and say, all right, we're speaking about reaction 3, which is elimination. So we need, in elimination, we need a concentrated strong base. That one is in reaction 3. So in 3, which is elimination, we need concentrated. Right? In 3 must be concentrated. That one is elimination. And during substitution, which in this case was reaction 4, you need the dilute solution. So in 4, you need dilute solution. Those are the difference between the two of them. We have the similarities, which is a strong base. Both of them must be strong base, but we have the differences, which is during the elimination reaction we need a concentrated solution, and during the substitution we need the dilute solution. I hope it's clear here. Moving on, write down the balance equation for reaction 2 using structural formula. Reaction 2 is addition. We're going from alkene to haloalkane. So we have to write the reaction. We're starting with compound Y, which is an alkene. We don't know which alkene, but we have to come to compound Z. And they say prop. Remember, in previous video, we mentioned that the number of carbons stay the same. If you didn't watch it, please go back and watch those videos. I'll leave the link. If we're starting with prop, then it means here also was prop. Okay, that is the thing. Okay, so this is the general reaction. We start with alkene, we add hydrogen halide, we end with a haloalkane. In this question, they gave us the product. This one was 2-bromopropane. We're starting from the back. So it means that the hydrogen halide used was hydrogen bromide. That was used. How do I know that? Because of the bromo. This bromo must come from here. Okay? And then the alkene must be propene. So this one must be propene. But let's say you are not sure about the alkene. Then you start from the back. We have prop is 3. Okay, this is what we have. Remember the arrow here. Right? We have hydrogen bromide. And now, which one was the alkene? Also alkene with 3. Also an alkene with 3 carbon. There we go. 1, 2, and 3. Okay. Now the double bond, because it's 3 carbon, was in either side. You need to remember always that the hydrogen was added to the carbon that has less number of hydrogen. So here in this case was in this way. There were 2 hydrogens here, hydrogens there, hydrogens here, in this specific way. The hydrogen was added to the second carbon because it has less hydrogen. Please, you can go and watch the video about this explanation. And this one is the reaction they are looking for. If you say this one, you'll get 3 marks, and it's quite simple, guys. Really, really simple. Okay, so we are here. Name the type of substitution reaction represented by 4. Now, in this reaction, we're starting from alcohol. We're going to haloalkane, that is hydrolysis. Hydrolysis is quite important reaction. It is hydrolysis. So let's write it down here also. That is the type of reaction. Write down two reaction conditions for reaction 2. Reaction 2, we have hydrohalogenation. So you have to make sure you identify the reaction. If that one was wrong identified, you won't get the condition, guys. And those conditions, first, you need an unreactive solvent during the hydrohalogenation, and they cannot be water. So no water present. No water present. And that is the two condition for this type of reaction 2. Remember, we already mentioned that reaction 2 is hydrohalogenation, and we already did the equation, the balance equation for that reaction 2. Question 7.7, using molecular formula, write down the balance equation for the complete combustion of compound X. We already spoke about compound X is an alkane. It will be, now, if we start in here with propene, it means this one is propane. So it's a lot of things here. Propane, that is the compound we're speaking about for compound X, okay? So now, combustion. Combustion is also simple. There is a video on that one. I'll try to leave the link below for you guys here, okay? But now, this is easy to get marks here. Combustion of compound X is an alkane. You will add O2, that is always the reactant, and you will get H2O as well as CO2. That is the general equation. In this case, we have compound X, which is propane. Propane is C3H8, all right, plus O2, and this will give you H2O, CO2. If you do that, you'll get already 2 marks. You'll get 1 mark for the reactant, and you'll get 1 mark for the product. It's simple. The rest is to balance the equation. This balancing was not problematic, but let's have a look. When you balance this combustion reaction, you leave oxygen always for last. We have in 3 carbons, we have in 1 carbon. I'm going to add a 3 at the front. We have in 8 hydrogens. Here we have only 2 hydrogens, so I'm going to add a 4. 4 times 2 is 8. Now oxygen, I have 2 on the left hand side, and on the right I have here, if I go here, I have 4 oxygen plus 3 times 2 is 6, and that gives me 10 oxygen. Therefore, I have to write a 5 at the front. And the final answer will be like this: C3H8 plus 5 O2, and then 4 will give you 4 H2O plus 3 carbon dioxide. Guys, this one is the end of this specific question. I hope it helped. If it helped, don't forget to subscribe to the channel, to write comments, to thumb up, and I'll see you next time. Mr. G